Welcome to all of you Shiksha 360, and today basically we will discuss under the ABM MCQ series, that is set number 13, and this set number 13, it is basically belong to the case study, clear case study. In that basically we will discuss one case study. And that case study is basically totally based on the probability table, clear, that is basically based on the probability table, clear. So let's start our discussion. First of all, we will see here on the screen that is a probability table, clear. Here basically there is a one variable that is z, clear. There is a one variable that is z, and on that basically we have a values, clear. And here that basically we have values also, clear. Basically we have values 0.00, 0.01, 0.02, 0.03, clear. In that way basically we have here values. Similarly here, like basically z is equal to, we have z is equal to 1.67, clear. Z is equal to 1.67. So what is the probability value, clear? So what is the probability value of that, clear? So what is the probability value of that? Basically, if the z is equal to, we can say that 1.67, clear. Z is equal to 1.67. So let's just simple. Here basically we have 1.6, and on the other side basically we have to find that 0.07, clear. Just basically we go to that row. So this one is the value of 1.67. That is 0.4525, clear. That is 0.4525, clear. On the basis of that, basically we have to solve the question. Just let's start our discussion and try to understand basically what the question says. That if you are able to understand one question, definitely you are able to answer the other questions also. So let's start first question. So in a sample of 16 observations, here n is equal to 16. From a normal distribution, clear, in a sample of 16 observations from a normal distribution, basically with the mean of, here they have mean given is that is 150, and the variance given they give, variance given here is 256, clear. Variance given here is 256. One more thing here, basically in the examination, basically they will not give you the probability table, clear. Just basically they give the values, clear. Just they give the values like given here, clear, like given here to solve the question, clear. To solve the question basically just they give the values. So here basically what is the probability, clear. Basically P stands for probability. If x bar greater than 142, clear. Basically if x bar basically greater than 142, clear. So what is the probability value? What is the probability value if x bar greater than 142, clear? So let's start our question. N is equal to 16 given here. Mu mean is equal to 150. Variance given here, that is 256. If variance, that is basically known as sigma square, standard deviation square 256. So sigma here comes out to be square root of 256. That comes out to be 16. That comes out to be 16. And we have to find that the probability x bar greater than 142. So what is the formula for that? That is z is equal to x bar minus mu upon sigma x bar. Clear, sigma x bar. How we can calculate the sigma x bar? Sigma x bar basically we know that is equal to sigma upon root n. Sigma upon root n. What is the value of sigma here? 16. N is equal to 16. Root n, root 16. So 16 upon 4 is comes out to be 4. Clear? So sigma x bar comes out to be, okay. So sigma x bar comes out to be 4. So put the value here. Basically we have given that is x bar that is greater than 152. Sorry, 142. That is basically this one. So z is equal to 142 minus 150 mu upon sigma x bar, that is 4, is equal to minus 8 upon 4. That is minus 2. Okay. So here basically we will get that is minus 2. So now move to the value, or basically you can check here also, or that is basically we can go through the table also. Clear? Here we know that basically the value of the z, basically ignoring the minus sign here, z is equal to 2. when the value probability is basically when the value of the z is equal to 2, the probability value is basically 0.4772. 0.4772. Clear? So basically what they are asking here, basically what is the probability x bar greater than 142. So let's understand what is the answer. Basically they are asking in this way. This is the diagram. This is the diagram. This is the mu. Clear? Same side. How portion same here, portion same here. Clear? Figure is not up to that much level, but you can understand it. Clear? Mu here basically that is 150. So 142 lies here. Basically we can say that we know that this one is also total area under that. Total area under the curve is to be 1. So on left hand side of the mu that is 0.5. On the right hand side of the mu that is 0.5. Okay. Only after that basically it leads to the overall area 1. And here they are asking basically what is the probability if x bar greater than 142. That is basically they are asking basically this is the 142. They are asking overall this one. Okay. And we know that the area behind under this one, under this specific area basically where we have made the cross mark or boxes, we know that the value of that is basically 0.4772, and the value of that is basically after the mu this one 0.5. So overall area here is 0.5000 0.4772, that is 2779. 0.9772 overall area here basically that is 0.9772. So what is the answer here? That is option number C, the correct answer. That is 0.9772. 0.9772. Because they are asking the area basically greater than 142. That is what is the probability value. Clear? This is basically the area. Now what basically we have calculated, that is area. Sometimes basically they are asking that is Px bar less than 142. Just basically we have to subtract it basically from 1. Because we know that overall area is to be 1. On the reverse side basically this one is our answer. So please tell fast, this question is clear to all of you or not? Because this is the concept and basically you will get these types of question in the examination. These are not typical question, just basically you have to understand the concept. Okay, in the class also basically we have discussed these types of things in detail. Now move to the next question, and I request to all of you please attempt that question and try to answer the question. Same question. In a sample of 16 observations from a normal distribution basically with the mean of 150, that is mu here 150, sigma square that is 256, it leads to sigma is equal to 16. Probability value here is given. If instead of 16 observation, here in the previous question basically where n is equal to 16, here n is equal to 9. So the new sigma x bar is equal to sigma upon root n. 16 upon root 9. 16 upon 3. Okay. This is the new sigma x bar. Clear? This is the new sigma x bar, that is 16 upon root 9. So basically when we are trying to solve this one, basically we will get like I think 5.33. Please tell fast if I at any place I am wrong. Clear? Sometimes basically 5.33 basically here we will get. Now just what we have to calculate, P probability at x bar less than 160. So let's try to solve that. Z is equal to x bar minus mu upon sigma x bar. So x bar here that is 160 minus 150 upon 5.33. 10 upon 5.33. When we are solving this one, basically what we will get here, 10 divided by 5.33, basically we will get here 1.876, which basically we will round off 1.88. 1.88. Clear? Basically we will round off. Clear? 1.88. So basically we have to calculate less than 160. So that is basically if the diagram is like this one. Okay, I will draw here. Okay, so 150 here, 160 here. So 0.5 is already added and we have to calculate this one. Z is equal to, basically we know that that is 1.88. What is the value of 1.88? Check here, basically they have given that is 0.4699. Just add that 0.4699, 0.5000, 0.9699, 0.9699. So option number B is the answer, that is 0.9699. Okay, hope this point is clear to all of you, basically how to solve this type of question. Clear? In the examination, basically you will get these types of question. Not any typical question, just basically you have to understand the concept, what they want to say here. Now move to the next question, that is question number 159. Here same question, if instead of 16 observations, 9 observations are taken, n is equal to 9. Find the probability x bar greater than 142. Same question or different? Same question, I think. I think we have written here same question, that is x bar greater than 142. But one thing they have changed here. In the previous question, basically we have n is equal to 16. Here n is equal to 9. So let's solve that. Sigma x bar, we know that that is 5.33. So probability, first of all, we have to calculate Z. 142 minus 150 upon 5.33. Z comes out to be basically 8 upon 5.33. 8 divided by 5.33, which comes out to basically 1.5. Value of Z is equal to 1.5, that is probability is 0.4332. 0.4332. In that, basically we have to add 0.5000, 0.5000, 9332. This one is our answer. This one is our answer. Clear? Hope this point is clear to all of you. Just what we have to do here, we have to understand the concept. We have to understand the concept. If we are able to understand the concept, basically we will be able to answer the question. Clear? We will be able to answer the question. Now move to the next one question that is little bit different from that. Let's start also. Not here, basically we have to always add 0.5. On the basis of that, clear, on the condition. Here, this one is the graph. And this is the 150. This is the 142. They are asking the area that is basically greater than 142. That is this all area. So this area, that is, we know that this one area that is equal to 0.5. We add this one. Okay. So sometimes basically they are asking the area between 142 and 160. In that case, we are going to calculate only this one area, area between these two lines. It depends upon question to question, basically what they want to ask here. What they want to ask here. Clear? On the basis of that, we have to solve. Now move to the next question and last question of our today's session. Question number 160. From a population of 75 items, that is capital N is equal to 75, with the mean of 364 mu and a variance of 18 sigma square, 32 items were randomly selected without replacement. That is small n is equal to 32. They are basically randomly selected without replacement. So what is the probability that X lies between 363 to 366? 363 to 366. So basically in the case of finite population, clear, in the case of finite population, how we calculate sigma x bar? How we can calculate sigma x bar is equal to sigma upon root n Clear? This formula basically which I have written here, that is basically without replacement. Clear? This formula basically without replacement. Bracket capital N minus small n upon capital N minus 1. This is the way of calculating sigma x bar. So put the value here, sigma here basically under root 18. When we are going to calculate under root 18 here, what is the value here? We can say that under root 18 is just is equal to 4.243. Under root 18 is equal to 4.243. Put the value here, 4.243 upon under root n, that is under root 32. Capital N 75 minus 32 upon 75 minus 1. So please try to solve this question. What is the value here? Try to solve this question. So when we are trying to solve this one, 0.243 divided by root 32, we will get here 0.75 into 75 minus 32 divided by 74, square root of that into 0.75. I will get here basically z is sigma x bar here is equal to, please tell fast what is the value basically you will get here. Please tell fast what is the value basically you are getting here. Sigma x bar here basically we will get that is 0.57. Clear? 0.572 basically we can say that. Clear? Sigma x bar basically we will get here basically 0.572. Clear? Basically when I am solving here basically I will get here approximately 0.572. Okay, so now sigma x bar basically we will get here. Now let's put the value here, that is this one to this one. Clear? Basically between to this one to this one. So let's put here simple 363 minus 364 upon 0.572 x, 366 minus 364 upon 0.572. So here what we will get here, 363 minus 364 divided by 0.572. I will get here basically minus 1.75. Here 2 divided by 0.572. Here we will get here 3.5, approximately 3.5. This is the value we will get here from the table when p is equal to 1.75. 1.7, 1, 0, 1, 2, 3, 4, 5. 0.4599. 0.4599. And second one, the value which we will get 3.5. 3.5. This one. 0, 1, 2, 3, 4, 5. 0.4989 plus 0.4989. 3.5, 0.4589. Three point, sorry, 3.05. This is the value of 3.05. Clear? This is the value of basically 3.05, not 3.5. Clear? So 3.5 basically in that case where there is, that is basically we will take it as a 0.5, clear? 0.5, clear? 3.5 basically we will take it as a 0.5, clear? So what is the overall reason between that? What is the overall reason between that? Add both of them. 0.4599 plus 0.5000. 9959. 0.9599. 0.9599. This one is our answer. This one is our answer. Please tell fast if you have any doubt, any query. From here, after solving this one, we will get sigma x bar is equal to 0.572. Put the value here. Simply, we have put the value here and we calculate the area, which comes out to be 0.9599. Clear? 0.9599. Clear? So this leads to our answer is option number D. Clear? Answer leads to the option number D. Clear? In this session, basically, we have to discuss up to this much this much point. Clear? No need to confuse here. Just draw simply this one. This is the graph. What is the value of mean? 364. They are asking the area between 363 to 366. This one. We know that the area between 363 to 364, 0.4599, and between 364 to 366, 0.5. So overall area between them is total we have to add 0.9599. This is our answer. And if they are asking basically area, not between them, so we have to subtract it from 1. Here we have to subtract it from 1. Clear? In this way, they will ask question in any of the form. Clear? They will ask question in any of the form. So on the basis of that, we have to solve the question. Okay. So thanks to all of you for attending this session. Hope all of you are able to understand regarding the probability table, how to solve the question on the basis of that.